Okay, when using a burette to dispense a solution, you must fill the burette and then read your initial volume of your solution. In this instance, it is 0.19. Now you read this from the bottom of the meniscus right here, and then record your information in your notebook. 0.19 milliliters. Now you want to raise the burette because we had it at eye level to read the meniscus, so you want to raise it a little bit so you can actually get your flask of your other solution underneath. It's not quite far enough. You also want to make sure that the tip of your burette is below the edge of your beaker.
That was your final stuff, initial. I thought it was, my initial was...
You want to take your non-dominant hand and turn the drain cock to start draining, or start dispensing your solution into your flask. And you also want to take your dominant hand while it's draining and swirl the solution. The reason for the swirling is there is an indicator in this solution, and you must evenly distribute the fluid, the solution coming out of your burette in your flask to make sure you don't get a false reading. As you can see, as it's going in, you can see it's turning pink, but that's false. Because as you swirl it, it disappears because it's mixing with the rest of the solution. We want to mix it a little more slowly. So that means we're getting close to the end point, or the point where the entire solution is going to change to a different color, which means that the reaction is complete. Now the indicator has turned solution pink, which means it is fully mixed and the reaction has occurred. I also have a piece of paper underneath to make sure that you can see the proper color of the indicator solution. Now that the reaction has taken place, we want to read a final volume on the burette. I'm going to raise it up a little bit to eye level so I can see it. And the final volume is 33 points.
Alright.
4-1. We're going to record this information in our book. And that's how you use a burette.
We use titration technique in order to find the concentration of analyzed solution, which means it's a solution that we know the concentration of it. So now, first thing, we pour our solution, which is sodium hydroxide. Here, we pour our burette with this solution, and then we bring the burette into our eye level so we can record our initial volume, which is 0.51, and then we're going to write it down. Then we adjust back our burette. And start the titration. We have to make sure that the tip of our burette is below the edge of the Erlenmeyer flask that we've got here. And then we start titrating. At the same time, we start swirling the flask. end point, which means that our reaction is complete and we can observe the pink color.
Yes, sir. So the KHP in the first radiant, and then the acid. I think it goes right.
Not there yet. Be really careful. Yet. Color is not yet stabilized, so we haven't reached our end point yet. Hopefully we will get it soon because my partner is so tired of me.
I think it's there.
Yeah, I think we've got the pink in the end. Yeah, this is the end point that we were looking for, so our reaction is complete. And we need to record the final volume, which is 36.72. Which is going to be our final volume, and that's how we use the titration. Yeah, this is the color we were looking for, and we've acquired it. Yeah.
In order to perform a titration using a burette, first we should clean the burette 3 times with deionized water and 3 times with the solution we're going to use. In our case, it should be sodium hydroxide. And after the cleaning of the burette, we fill the burette with the solution. And now we've already filled it, and what we need to do is read the initial volume before we start titration. And in this case, it is 0.40, and we write it down in the notebook. And that should be our initial volume. And now we can perform the titration. In order to do that, we put the flask underneath the burette and make sure the tip of the burette is well below the rim of the flask, and use your dominant hand to swirl the flask, and use non-dominant hand to use the stopcock on the burette, and make sure the handle of the stopcock is between your thumb and index finger, and gently turn the stopcock from horizontal to almost vertical to let the solution drain into the flask, and use the dominant hand to swirl the flask during all this procedure. And pay attention to the color change inside the flask, and that should indicate the end of the titration. And
Alright, so you have an analyte solution, but you don't know the concentration of the analyte solution. But you need to find out the concentration. In order to do this, you want to perform a titration. Titration is a procedure in which you have a known solution, also known as a standard solution, which you know the identity and the concentration. And you use this solution and you mix it with the analyte solution through a burette. And you also want to make sure that you have mixed a small amount of indicator solution in the analyte solution, the unknown solution, so that you can observe the endpoint between the two reactions. In other words, it's going to change color when the reaction occurs to let you know that it has happened. If done correctly, the titration procedure will allow you to discover the concentration of the analyte solution, the stoichiometry of the reaction between the two solutions, the number of electrons gained in the redox reaction between the solutions, and the solubility of the products obtained from the mixture of the two solutions. Okay, when you're about ready to perform a titration, there are a few things you need to know before starting. When you're using your standard solution, you need to know the molarity of your solution or the concentration. It's the same thing by finding out moles per liter. And this capital M means molarity. You also need to know your initial volume. These will all be used in an equation in a minute. You also need to know the volume of your unknown analyte solution, also going in an equation. And you need to know how to identify the endpoint, or usually the point when your indicator solution turns the mixture a different color. This is the equation you know. Volume 1 times molarity 1 equals volume 2 molarity 2. Or in our instance, we're going to use volume of the standard solution times the molarity of the standard solution equals the volume of the unknown solution times the times the molarity of the unknown solution. There's very little data you need to collect. Really, what you have to collect is the volume of your standard solution that you are distributing into your analyte solution. This is done through the burette. You would read the bottom of the meniscus. You would fill the burette with your standard solution, and then you would read the meniscus, or the indentation here at the bottom, and you want to read it to the second decimal place. As I've shown here, we have 0, 1, 2, and 3. And then you have dividers. This would be 0.1, 0.2, 0.3, 0.4. So we know it's in between 0.3 and 0.4, so we want to guess the next decimal, which I've guessed to 0.8. So it would be 0.38 for our initial volume. And then after distributing some fluid, the meniscus would drop down, and we can see here it's between 1.1 and 1.2, and I've guessed the second, or 1.6 and 1.7, and I have guessed the second decimal as to 1.9, which is our final volume. Now you want to subtract your initial volume from your final volume, so it would be 1.69 minus 0.38, which would give us 1.31. This is the volume in milliliters that we have distributed into our analyte solution, and we would plug this into our equation down here. Whenever you use a burette, you must prime it before you use it. In order to do this, you want to first put a slight bit of deionized water in it, maybe a quarter to halfway up. Tilt it slightly sideways and then roll it around. Make sure it goes to the top of the solution, runs over the top graduation mark. You want to rotate it a little bit all the way around, probably 360, 720. Then you want to put it back in the stand that holds the burette and open the drain cock, let it drain all the way out. You want to do this 3 times with deionized water, and then you want to do it 3 times with your standard solution. In our case, it was sodium hydroxide. After that, the burette is ready to use.